Welcome to AI Podcasts. Today we're digging into FlashAdventure, a new EMNLP paper on whether computer-using agents can actually finish full stories in adventure games.
Adventure games, as in those point-and-click mysteries and escape rooms online.
Exactly. The authors built a benchmark of 34 classic Flash games and asked GUI agents to play from start to finish. The takeaway is blunt. Current agents almost never complete the story. A new memory-focused approach helps a bit, but humans are still comfortably ahead.
All right, big picture first. Why Flash games and why full stories?
Flash games are compact, free to run, and many have self-contained plots you can finish in about an hour. That lets you test what really matters for long missions. Not just clicking a button, but remembering something you saw early on and using it much later to solve the case.
So the classic detective moment. You talk to a suspect in the first scene, 4 scenes later you find the alibi, and only then can you clear their name.
Right. The paper calls that the observation behavior gap. Humans handle it almost instinctively. Agents, not so much.
Who's behind the work?
Led by Jaewoo and Gunhee Kim at Seoul National University, with collaborators from Crafton and Georgia Tech.
Got it. Now, if we're evaluating whole stories, you need a referee. How do they grade the runs?
They introduced something called CUA as a judge. Think of it as an automated game referee. After the agent stops, the judge takes control and actively clicks around the interface to verify progress. It might open a notebook to count suspects found or check a stat screen. In tests, its judgments match human raters about 94% of the time.
That's clever. It's like a lines person watching a replay and confirming the score. What about the agents they tested?
A mix. Well-known computer use stacks like OpenAI system, Claude's computer use mode, an open-source baseline, and their own framework layered on top of Claude. Each run is capped at 1,000 actions, so agents can't just wander forever.
And the headline results?
The best baseline hits only around 6% story completion across all games. Their framework, called Coast, nudges progress up, especially on intermediate milestones, but full completions remain rare. Meanwhile, humans clear about half the games under the same step cap, and with no cap, they finish almost all of them.
Oof. So even with modern models, finishing the story is still a tall order. What exactly is Coast doing that helps?
Coast stands for a clue-oriented agent that runs in a seek map solve loop. First, it actively seeks clues, not just clicking the most obvious next button. Then it maps those clues into a simple memory, linking what was seen to what might be useful later. Finally, it solves by turning that memory into subtasks. You can picture it like carrying a paper notebook through the game and sketching a little flowchart of who knows what and where to try next.
So it's trying to recreate what a careful player does. Look around, jot notes, then plan the next move.
Exactly. And the ablations show the mapping step is the backbone. Just seeking more clues or seeking plus trying to solve immediately didn't help much. When they added the mapper that links past observations to proposed actions, progress jumped.
Where do agents stumble the most?
3 big places: planning, perception, and what the authors call lateral thinking. Planning means agents get stuck in loops, like opening the same door over and over. Perception is basic vision. They miss tiny UI elements or small items tucked in a scene. Lateral thinking is the flexibility to try the non-obvious connection, like using a blue ball to knock down a keycard from the ceiling.
That sounds painfully familiar to anyone who has watched an agent demo click the wrong target again and again. Did Coast fix perception?
Not really. Coast helps with the long-term memory and planning, but it uses the same vision backbone as the base agent. If the model can't reliably see a small object, smarter memory won't make it appear.
Makes sense. What about genres? Do some subgenres help the agents more than others?
Yes, hidden object games are more about visual search, so memory helps less there. In narrative, heavy detective, or puzzle chain games, the clue memory matters more, and that's where Coast gains tend to show up.
I'm curious about contamination. These are classic games. Could the models have memorized walkthroughs from the web?
They checked. Claude showed no signs of contamination in targeted quizzes. GPT-4o did show some, but here's the twist. Even with hints of memorized knowledge, gameplay didn't improve. It knew some facts but still couldn't turn them into the right clicks and drags. The old knowing-doing gap.
That's a striking point. Knowing the solution isn't the same as executing it through a messy interface. Any experiments with giving the agent hints?
Yes, when they injected structured hints, like Oracle-style subtasks, the agent could breeze through a well-structured detective game. But in a tricky escape room, where you need sharp pattern recognition, even hints didn't save it. If you can't see the pattern on the wall, no to-do list will help.
Let's talk about limitations. What should we keep in mind before drawing sweeping conclusions?
First, runs are single-shot because of API costs. That raises variance and makes it harder to claim statistical certainty. Second, the automatic judge uses a particular vendor stack. It aligns well with humans, but broader cross-checks would build more trust. Third, Flash games are great for access and narrative closure, but they aren't modern three-dimensional worlds with complex cameras and HUDs, so generalization to big contemporary titles is still open.
What do you think this benchmark contributes that we didn't have before?
It puts a spotlight on story completion, not just short tasks. It gives a practical, reproducible way to score progress automatically, and it shows that a simple, explicit memory about clues can help an agent keep its head straight across long arcs. All of that gives the field a more honest bar to clear.
If you were building the next system, where would you invest?
3 places. Better visual grounding tuned for GUIs, so the agent actually sees small buttons and objects. Richer memory, not just a list of clues, but episodic notes about who, what, where, and when. And independent evaluators, so different judge agents can cross-validate each other the way human graders do.
Plus more than one run where budgets allow, so we know whether improvements are stable and not lucky breaks.
Exactly. Even small multi-seed studies on a subset would help.
All right, give me your one-line takeaway for folks who only caught the last minute.
Finishing the story is the real test for GUI agents, and right now humans dominate. Memory helps, but perception and planning bottlenecks still hold agents back.
And my add-on, FlashAdventure is a solid step toward measuring what matters. If you claim an agent can use a computer like a person, it should be able to close the case, not just open the menu.
Well said. That's it for AI Podcast today. If you enjoyed this breakdown, share it with a colleague who loves both language models and old-school adventure games.
Thanks for listening. See you next time.